Right, today's video, it's a crash course on problem solving involving circles. Right, let's look at this question. So you're given 3 points A, B, and C, and these 3 points lie on a circle, and we need to prove that AC is the diameter of the circle, and in part 2, find the equations of the circle. So to solve questions on coordinate geometry involving circles, it is always good to have a visual representations of how the points in the circles connect to one another. So let's start off with point A, point B, point C, and then of course a circle that passes through all these 3 points. Right, so what we're going to do is, we're going to draw a line from A to C. So, and then we're going to draw a line from A to B, and also a line from B to C. Okay, so if AC is the diameter of the circle, then this one will form a semicircle, right? And if it's a semicircle, then what can you say about angle ABC? So angle ABC will be 90 degrees. What is the angle properties that explain that angle ABC is 90? Yes, the angle property is right angle in the semicircle. If you have a right angle in the semicircle, that means AC is the diameter of the circle, and angle ABC will be 90. So if angle ABC is 90 degrees, what does that mean? It means that AB is perpendicular to BC. AB is perpendicular to BC. And if we can prove that AB is perpendicular to BC, right, then we can prove that angle ABC is 90 degrees. And if angle ABC is 90 degrees, then AC is the diameter, right? So our job now is to prove that the gradients of AB multiplied by the gradients of BC will give you -1. So let's go on to find the gradients of AB, which is 3/4, and then the gradient of BC, which is -4/3. So when we multiply these two gradients together, you get -1. So since you get -1, we can say that it satisfies the conditions m1 times m2 equals to -1. And if that is the case, it means that AB is perpendicular to BC. And if AB is perpendicular to BC, it means that angle ABC is 90 degrees. So using right angle in the semicircle equals to 90 degrees, we prove that AC is the diameter of the circle. So this is quite tricky. This is quite a tricky question because it involved two concepts here. Right angle in the semicircle equals to 90, and it also involved m1 times m2 equals to -1. Right, so let's come to the second part of the questions, asked to find the equations of the circle. So to find the equations of the circle, basically we need the center of the circle, and we also need the radius of the circle. So how is the radius and diameters connected to one another? Yes, the diameter is equals to 2 times radius. So if I can find the length of AC, divide by 2, that will give me the radius. And another thing to take note is the diameter AC will pass through the center of the circle. And since diameter is equals to 2 times radius, the center of the circle is actually the midpoint of the line segment AC. Right, so these are the concepts involved written on the screen in black ink. So our job now is to find the length AC using the distance formula. Right, if you're not too comfortable about substituting in directly, as I've mentioned earlier in the earlier video, you can always label your points. Okay, label your point as x1, y1, x2, y2, and then you do the substitution. All right, so you will get square root 50. Do not use a calculator. Do not use a calculator to evaluate because you have a lot of decimal places. So you apply the rules of surds that we have learned earlier on. Square root AB is equals to square root A times square root B. So 50, you can actually write it as 25 times 2. That will give you square root 25 times square root 2. Square root 25 is 5. That gives you 5 square root 2. So if the diameter is 5 square root 2, then the radius will be 5 over 2 square root 2. So we have successfully found the radius of the circle. The next thing is to find the center of the circle. So we're going to use the midpoint theorem. Okay, so we let the center of the circle be A comma B, right? So the midpoint theorem is x1 plus x2 over 2, y1 plus y2 over 2. So we found the center to be 5 over 2 and negative half. And then we substitute into the standard form of the equations. If you were to remember, standard form of the equations is x minus a squared plus y minus b squared equals to r squared, where a and b is the center of the circle and r is the radius. Alright, so the next question is rather tricky. Right, you have a line which is a tangent to the circle C at a point P 6, 6. So what do you mean? What is your understanding of the word tangent line? Yes, tangent line means it will intersect the circle at only one point. All right, and what are some of the concepts involving it? Right, tangent is perpendicular to the radius or perpendicular to the diameter. Okay, so we have a circle, we have the point P 6, 6, and we have a tangent line. And this tangent line has the equation 4y plus 3x equals to 42. All right, and that's a diameter. And of course, the diameter will pass through the center of the circle. The center of the circle is C. And we're asked to find the equations of this diameter. So like what we have mentioned earlier on, right, tangent will be, there's one property, angle property involving tangents and the radius, that is tangent perpendicular to radius. So if tangent is perpendicular to the radius, then of course tangent will be perpendicular to the diameter. Right, so from 4y plus 3x equals to 42, we need to find the gradient of this tangent line. So the gradient of this tangent line is negative 3/4, and therefore the gradient of the diameter will be negative 1 divided by negative 3/4. Because the two lines are perpendicular to each other, we are using m1 times m2 equals to negative 1. So therefore the gradient of the diameter is 4/3. And from there we can find the equations of the diameter using point P, because P actually lies on the diameter itself. So the equations you get will be y equals to 4/3 x minus 2. So for part 2, this is the most challenging part of the whole questions. Alright, so you're asked to find the possible equations of the center C. And this center C has a radius of 5 units. Right, so since the radius is 5 units that cannot be changed, then how to have possible equations of the circle? So it's only possible when you have different center, right? Different center but with the same radius. Right, so since point C lies on the diameter, and we have already found the equations of the diameter, which is y equals to 4/3 x minus 2. Right, so we can let the coordinates of point C, if we let the x coordinate be x, then the y coordinates will be 4/3 x minus 2. Right, so we're going to find the distance CP, because what would the distance CP represent? Yes, the distance CP is the radius of the circle. So if we use the distance formula, right, you will get x minus 6 squared plus 4/3 x minus 2 minus 6. And that give you 4/3 x minus 8. Right, and that would be equals to the radius of the circle, which is 5 units. And then how do we get rid of the square root sign? Basically, you square both sides. So you square 5, you get 25. And these two, you have to use the expansion, this algebraic expansion. All right, to expand it. Okay, and highlighted in yellow is when you take x squared plus 16 over 9x squared, you get 25 over 9x squared. Highlighted in blue is negative 12x minus 64 over 3x. You get negative 100x over 3. And 64 minus 25 plus 36 will give you 75. So how do I get the next step here? I basically just times 9 throughout. I just multiply with a 9 times a 9 times a 9. So I end up getting 25x squared minus 300x plus 675. And when I use the calculator to help me factorize it, I'll get x equals to 9 or x equals to 3. Alright, so we're going to substitute x equals to 9 into the center of the circle, and you will get 9 comma 10. And from there, you can substitute into the standard form of a circle to get the first possible equations of the circle. Okay, first possible equation. How to get the second possible equations? Okay, remember we also have a second values for x, which is x equals to 3. Right, so the center will be 3 comma 2, and likewise you substitute into the standard form and you will get the second possible equations of the circle. Right, so this ends the problem solving on circles.